In this lecture, we will learn about the derivatives of logarithmic functions. Suppose the function f of x is ln of x, natural log of x. Then we want to derive f of x. So derivative of f of x is 1 over x, which means we are doing derivative of the function f of x. The function f of x is natural log of x, ln x, and the derivative of ln x is 1 over x. If the function is log x to the base a, but we have a base now, so the derivative of the function will be 1 over ln a times x. So for example, suppose we are doing derivative of log x to the base 2, your answer will be 1 over ln 2 times x. Next is derivative of natural log of g of x. So you have natural log of g of x rather than natural log of x like the first property. So you have to understand that you have to do a chain rule of differentiation now. So derivative of f is 1 over g. Derivative of a function natural log gx, you do first 1 over g. Then you want to derive the function g, which is a chain rule. Natural log of g of x, but with a base a. If you have a base a, you have a ln and that particular base number, which is a in the denominator. Then you start deriving g of x, natural log of g of x, which is 1 over g of x times ddx of g of x. First the outer function and then the inner function. So let's do this example. Function is sine of natural log of x and we want to derive this function. So derivative of f of x, the given function, is derivative of the function sine of natural log of x. Derivative of the sine function, you read the sine function first. Derivative of sine function is cosine function, the outer function. So we're going to write cosine of natural log of x. Then you want to move inside. You want to derive this ln x. So I'm going to write ddx of ln x. And it turns out that the ddx of ln x is 1 over x. So write 1 over x. So we did derive the outer function first, and then we did derive the inner function second. So this is the chain rule of differentiation with a natural log term. Next is natural log of 3 times sine square x. So you have to read this as natural log of g of x. G of x can be compared to 3 sine square x. So the formula says, we did discuss 4 formulas when we started this section. So if you are deriving natural log of the function g of x, all you do is first do 1 over g of x. Natural log of any function is 1 over the same function. So you write 1 over g of x. Then you want to derive this g of x. So ddx of g of x, derivative of the inner function g of x. So let's do that here. ddx of f of x is ddx of natural log of 3 sine square x. So derivative of natural log of any function is 1 over the same function. So the function is 3 sine square, so write the same. Then you want to derive the inner function. Inner function is this 3 sine square, so derive it. Now derivative of 3 sine square, 3 is a constant multiple, so you can bring it out in the next step. So it's 1 over 3 sine square x times 3. Now you're trying to do derivative of sine square x. When you do derivative of sine square x, you want to look at the exponent first, 2. So do the power rule. It is 2 times sin x. So it's sin x to the 2 minus 1, 1. So you don't write it specifically. But you understand that you did a power rule for this particular term to get 2 sin x. Well, we did differentiate the power 2. But we have not differentiated the inner function, which is the sin x itself. So now derive sin x and your answer is cosine x. So we did chain rule twice in the problem. Next one, sin x ln 3x. You have to read this very carefully. Read it as product of two functions. The first function is sin x and the second function is natural log of 3x. Product of two function is always product rule. So let's do the product rule. But while doing the product rule, you will see a chain rule. Also, you will see the logarithmic derivative rule. So you can write u is the first function sin x, v is the second function natural log of 3x. So you want to find the corresponding u prime, which is cosine x, and v prime, natural log of any function. When you derive, all you get is 1 over the same function. So it's 1 over 3x. Now derive the inner function 3x again, you get 3. So this dot here is from the chain rule of differentiation. Now you're good to plug in back into the formula, which is the derivative of f of x, which is derivative of u times v. We did rename the function as u and v. The formula says it's uv prime plus u prime v. So plug in back, u is sin x, v prime is 1 over x because you can cancel this 3 and 3, plus u prime is cosine x, and v is natural log of 3x. In the next example, you are given natural log of a quotient function. So you want to read this as natural log of any function, this entire function, treat it as a g of x. Natural log of g of x, if you want to differentiate this function, your answer will be 1 over gx, exactly the function, times you want to derive the function, inner function g. So let's do the same. Let me write this as f prime x equals 1 over the function 2x plus 1 the cube divided by 3x minus 1 to the 4. Then you have ddx of the entire inner function, which is 2x plus 1 the cube divided by 3x minus 1 to the 4. So for this particular step, we did apply this formula here. Now, you want to do derivative of this quotient function. So you have to read the numerator carefully, rename it as u, derive the denominator carefully, rename it as v. So let me list here. U is the function 2x plus 1 cube and v is the function 3x minus 1 to the 4. So find the corresponding u prime and v prime for the problem. U prime, first derive this power, which is the power rule. It's 3 times 2x plus 1 square. You do the power rule. Now move to the inner function. Inner function is 2x plus 1. Derive this and your answer is 2. Similarly, derive 3x minus 1 to the 4. You see the exponent is 4 here, so do the power rule. So it's 3x minus 1. The new power will be 3. 4 minus 1 is 3. Now you want to carefully read the inner function, derive it again, and you have 3. So you have u, v, u prime, v prime. Now you want to plug all these in the quotient rule formula. So to derive this particular function, you have to do a quotient rule. So let me write the quotient rule. ddx of u over v is v square, square the denominator, always start with the denominator v, then write u prime negative u v prime. So let's plug in all the function and the derivatives here. So the denominator will be 3x minus 1 to the 4, and then you have a square. Numerator will be v, which is 3x minus 1 to the 4, and then you have a u prime, which is 6 2x plus 1, the square. I'm multiplying this 3 times 2, I'm writing it as 6. And then you have a negative. Then you have u term, u is 2x plus 1 to the 3, and v prime, you can multiply the 4 and 3. So you have 12 times 3x minus 1 to the 3. So all this is the derivative of u over v, which is this quotient term here on the left. So now you're good to plug this back into the formula for quotient rule and rewrite the term. You have 1 over this entire term in the denominator. So you can take this to the top, flip it. It's 3x minus 1 to the 4 divided by 2x plus 1 to the cube when you flip the term. And derivative of all these quotient term here, we did find that this is 3x minus 1 to the 4, 6 2x plus 1 square, negative 2x plus 1 cube times 12 times 3x minus 1 cube. The entire function is divided by 3x minus 1 to the 4, and then you have a square. You can also write this as 4 times 2, 8. So this is your final answer. Next expression, natural log of x plus square root x square minus 1. I want you to read this entire function here within the brackets as a g of x. And the formula you will apply is d dx of natural log of g of x. Derivative of a natural log of any function is 1 over the function 1 over g of x times derive g again, derivative of g of x. So let's do this. So you're going to write derivative of h is h prime, and then derivative of ln on the right hand side is 1 over x plus square root x square minus 1, because it's 1 over g, times g prime, which means you're deriving the function in the bracket. So derivative of x is 1. Derivative of square root function is 1 over 2 times the square root function. But also make sure to derive the inner function x square minus 1, which is 2x. So we did a chain rule after doing a power rule, which is derivative of square root function is 1 over 2 times the square root function. So now let's simplify this. This is 1 over x plus square root x square minus 1. Let's make a common denominator for this, which is 2 times square root x square minus 1. And then the numerator will be 2 times square root x square minus 1 plus 2x. I'm making a common denominator for the fractions on the right hand side. Now you're good to rewrite this as 1 over x plus square root x square minus 1 times, you can factor out 2, square root x square minus 1 positive x. In the denominator you have 2 times square root x square minus 1. And now you see that you can cancel 2, and you can cancel this term. All of the product terms, any similar term in the numerator and the denominator can be cancelled. So all you have is 1 over square root x square minus 1, and this is the final answer for the derivative of natural log of x plus square root of x square minus 1. And this is your final answer. In the next example, you are given a function and you're asked to find the first and the second derivative. So let's do that. Y prime, you have product of function x square and ln x. For product of two functions, so it's a product rule. Fix x square, derive ln, so it's 1 over x. Fix ln x, derive x square, so it's 2x. Now you can simplify this a little bit by cancelling the x and the exponent. Then you have this y double prime, derive x, which is 1. And when you want to do this again, you have a product rule here, product of two functions. So fix ln, derive 2x, which is 2. Fix 2x, derive ln x, which is 1 over x. And now again you can cancel these x terms. So we did the product rule twice. So your answer is 1 plus 2, which is 3, plus 2 ln x. This 2 ln x is here. And 1 plus 2, you're writing it as 3. In the next example, you are asked to find the equation of the tangent line to the given curve at the point 3, 0. So identify the first value as a and the second value is the functional value at a. Do write our tangent line equation, which is y minus f of a equal to f prime a times x minus a. Plug in the value for f of a, which is 0, and a is 3. You want to find this f prime a, which is also the slope of the given curve at a. And in particular, you want to find f prime 3 because you know that a is 3. So let's find this. So the function is y equal to natural log of x squared negative 3x plus 1. Derivative of any natural log function is always 1 over, you can write it as y, you can write this also as f of x. So I can write this as f prime when I derive. Okay, derivative of any natural log function is 1 over x squared negative 3x positive 1. Now you want to derive this again, derive this denominator, the inner function. So you have 2x minus 3. Now plug in f prime at exact value given, which is 3. Simplify, you have 1 over 3 square, negative 3 times 3, positive 1, and then you have 2 times 3, negative 3. When you simplify, you get this as 2 times 3, 6 minus 3 is 3 in the numerator, 9 minus 9 cancels in the denominator, you have 1, so your answer is 3. Now go back, plug in here, it's y minus 0 equal to 3 times x minus 3. Simplify, you have y equal to 3x minus 9, which is the equation of the tangent line to the given natural log curve at the point 3, 0. So we'll end this lecture here.